What are we looking at? 26 through 30. 5 examples of a similar question here. 26 was finding the y-intercept of different functions, so I put 5 different functions here. And why am I asking this question? Well, y-intercepts are found by plugging in 0 for x. Why 0 is so important? Well, so many experiments start when, the timer reads 0, and then you measure from there. It's the easiest number to measure from. 100-meter dash. It's 0 when that clock starts. You can almost think of it as an initial condition. Right? So we want to know that if I ask you to find a y-intercept, that you plug in 0. So we got a y. So y of 0 is the first problem. It's the first problem I'm doing. And you can see that. I plug in 0. I get 0 minus 2 times 0 plus 4. Sure looks like y of 0 is equal to negative 8. 0, negative 8 is on that graph. The y-intercept. I need an eraser. Yep, I got it. Okay, so that's the first one. And you're looking at the second. And I'm asking the same question. With the y-intercept. So that means I put 0 into the y function. 2 times 3 will be 0 minus 4 plus 5. I've replaced x with 0. You got to be able to do the math. 2 times 3 to the negative 4 plus 5 is equal to 2 times 3 over 1, 1 over 3. This becomes 1 over 81, right? 3 to the 4th is 81. Then showing up a bunch of our other previous videos here. Plus 5. Well, you can either call that 5 and 2/81ths, or you can multiply by 5. 405 plus 2 is 407. Tired brain here, but I think I stated a correct amount. So either or, that takes care of that one. And now we got a kind of a funky function here. All right, so y of 0 is equal to 5 times 0 to the 3. Well, that's not too bad. That disappears. Plus 2 to the 0 plus 9. Really hoping that you know that 2 to the 0 is 1. So the y-intercept is 0, 10. 2 more. Geez, I wonder how you find a y-intercept. Oh, did you say plug in 0 for x? You'd be right. So that gives me y minus 4 equals 2/3. I'm going to plug in a 0 for x. 0 minus 8. Well, I know that y value is negative 16/3 plus 4. And I know 4 is negative 16/3 plus 12/3. Sure looks like if I put a 0 into this function, I'm getting minus 4/3. And we got one more. I don't know, how do you find a y-intercept? Oh yeah, you plug in 0 for x. If we plug in 0 for x, yes, you can see that. When our y value is 2 times 0 plus 25 minus 3. 2 times 0 disappears. The square root of 25 is 5 times 2 minus 3. It looks like if I put a 0 in, I'm getting a 7 out. All right, moving on down the line. Some function questions. Yeah, I'll just change the functions and we'll do the same 3 questions. F of 6. I got to do F of 6 first. I got to put 6 in for x. Looks like 3 goes into 6 twice. Times 2 is 4. Minus 7 is negative 3. So now I'm doing g of negative 3, which is 5 times negative 3 plus 2. Sure looks like that's minus 15 plus 2 or minus 13. So what was g of f of 6? Minus 13. Okay. And another way of writing for your SATs is g of f of 6. I think SATs tend to ask it that way. So you want to know that. All right, so now we got to do the inverse. And I'll do an h of p of x. Call h of p there. F minus 1 of x is the inverse of this function. All right, so how do we find inverses? We did 5 of those problems earlier on the test. We pretend there's a number here and we're solving. So n plus 7, I'm going to put that in parentheses because then I'm going to multiply by 3 and then I'm going to divide by 2. So it looks like my function is 3. I mean, I suppose I could multiply this out. 3 times x plus 21 over 2. And we check that with a number. We'll put the number 3 in here. The 3's cancel and I get -9. So does -9 come back to 3? -27 plus 21. Did I make a sign error here? So what did I say? Put a 3 in. 3's canceled, -9. So -27 plus, -6 divided by 2 is -3. So what is going on there, Jimbo? You put a 3 in, 2 minus 7 is -5. There's my tired brain. All right, so good thing I checked this. So let's put -5 in and see if it comes back to 3. -15 plus 21, 6 divided by 2 is 3. Okay, so I'm just having a little trouble with addition and subtraction right now. I've been doing a lot of math today. All right, so there's the inverse of that. So we'll take the inverse of p of x as our next problem. And I'm writing out, oh yeah, brain is tired. P minus 1 of x. All right, now the shortcut to finding an inverse at 7 is to realize that g of a equals 7, then g inverse of 7 equals a. So the shortcut is to take 5x plus 2, which is the g function, and set it to 7. And we can see that x is 1. 1 times 5. I'm sorry. Where was I? So the inverse. So that was just finding the so g of 1 gets us 7, and inverse of 7 gets us. Okay. So if I wanted the inverse, I guess I've got to do x minus 2 over 5, and then I could have put 7 in. 7 minus 2 is 5 divided by 5 to get our answer. But when you're given a number, just set the original function to that number. It's a little shortcut. That's why I was asking that question, because we practiced getting the inverse earlier. All right, so let me come up with some new functions for, let's do h minus. All right, so let me get some new functions here. I don't know, might not do 5 of these, we'll see. So h of x is equal to, how about we do x cubed plus 2, and let's do p of x. P of x is equal to 2 to the x. All right, let's play with those. And let's do h of p of, let's see, how about we do h of p of -1. That'll give you some fraction practice. All right, so we got to do p of -1 first, which is 2 to the -1, which is a half, right? Reciprocation. Now we got to plug in a half. We got to cube it and add 2. That's an 8. And 2 is 16/8. So it sure looks like this is 17 over 8. And remember, h of p of -1, when you get to your SATs, h of p of -1 is the same as that. All right, so the inverse of p. Now, we did that earlier in this test too. The inverse is a logarithm. Log base 2 of x. I think you got to learn that. I think you probably have to hear that a bunch of times. Let's get over here and not be able to see these things too easily. Now you can. All right, so 2 to the 3 is 8. 3 gets you 8. Log base 2 of 8 is 3. So you can see that. All right, and so now we're going to look at the inverse of 7. Oh, I got to make something up here. So let's do h, the inverse of about 127. Okay, so when you're given a number, you can go back to the original set it equal to that number. How are we gonna solve? Using inverse operations, dividing by 2 and taking the cube root. And the cube root of 125 is 5. All right, so what's the inverse of that? X minus 2, and then the cube root, right? And if you would put 127 in here, I hope you can see you get 5. But immediately setting it equal to 5, setting it equal to 127, saves you a little time, just a little bit. All right, so let's see, what can I ask next time here? Let's go back to f of x. F of x, let's do x plus 5 over 3. And let's do g of x is equal to, what should I give you? How about the square root of, let's do 2 times the square root of x minus 3 plus 4. All right, and let's do f of g of, oh, how about 28? Right, which is the same as f of g of 28. All right, so we're plugging 28 into the g function, and that gets us 2 times the square root of 25 plus 4, which is 14. And then we got to plug 14 into the f function, and that's going to get us 14 plus 5, 19/3. That's called a composite. Okay. Next one, let's do the inverse. The inverse of that. Right? So we're going to set x plus 5 plus 3. We're going to pretend we're solving it for a number. So what would you do? You'd multiply that number by 3. And then you would subtract 5. But we'll call this a function by replacing that number with the letter x. And so I've got 3x minus 5. And we check it. Let's put it, let's see, so what's easy to plug in here? Multiple of 3. How about we put a 1 in? 1 plus 5 is 6 divided by 3 is 2. If f of 1 gets me 2, then the inverse of 2 should get me 1. Let's put a 2 in here. 3 times 2 is 6 minus 5 is 1. Okay, that's good. I don't have to check that. And how about we say g of x is equal to the inverse of g is equal to, I don't know. How about 24? All right, what's the quickest and easiest way to get that answer? Is to come over here and set this equal to 24. All right, so subtract 4, that's 20. Divide by 2, that's 10. Undo square rooting with squaring, that's 100. And then add 3. So 103. All right, we're just going to say that's enough of those problems. Shortcut it just a little bit. Pretty straightforward stuff. Now we're going to go down the line. We're going to write these equations quickly. This is a square root function. It's the inverse of the squaring process. And I'm going to write x minus 8 plus 3. I know my y value from 3 to 29. It's got to go up 26. But when I put a 15 in here, I get the square root of 7. And the square root of 7 plus 3 does not take me to 29. No, get rid of it. Divide by the square root of 7 and bring in the number that will take you to 29. Okay, so we'll just do some of those quickly. You're pausing the video as always. So y equals, I see the square root function, x plus 9 plus 2. When I plug in 9, I get the square root of 0. That square root isn't 0. Whoops, that square root there is getting closer. Well, that's getting closer. That's getting closer. Ah, you know, when there's no area, there's no square root. That's going to get me a minimum or a maximum based on whether I'm multiplying by positive or negative. That's the geometric significance. All right, so x plus 9. I want a 2. Got a marker. I plug a 1 in, I get the square root of 10, which added to 2 does not take me to minus 5. From 2 to minus 5 is minus 7. You should be able to see the pattern now. So, pause the video. You try this one. I'm just going to write the answer. 0, 0. I do not need to write x minus 0 plus 0. I can just write the square root of x. And if I put in a 10, I get the square root of 10, not 11. Now I get 11. Next one. Oh, looks like I got another negative square root function here. So let's write y equals the square root of x plus 4. That gives me my minimum. And of course, I'm going to get a maximum with a negative multiplier. I want 7, so I write 7. I drop in a 1, gets me the square root of 5. I don't want the square root of 5. 7 to negative 1 is down 8 units. Last one. You can see everything there. Square root of x minus 59 plus 74 gives me the correlation I want and the signature type of graph. I drop in a 62. I got to get rid of the square root of 3. That's the change. And that's the operational change. And from 74 to 80. Oh, that's up 6. Yep. Interesting. No, not that it matters, but 6 could have been written as 2 times 3, and 3 is the square root of 3 times the square root of 3. And if I'm dividing by the square root of 3, the 3's cancel, and this thing could have been written as 2 root 3. And why do I say that? Because I want you to know what the square root of 3 is, 1.73, which means you could get a feel for that value. All right, I'm done. I'm getting silly here. Oh, I can do that on my own time. I'll shut this video down, upload it, getting close to the 50, getting there.